Verbal questions, Carter.
Isn't the load factor for 30% bag 1.15, 1.3? I was just curious because I know it's like what the cosine of 30 is your load factor.
See, I'm getting it from the chart that's provided in your figure supplement.
Okay.
Check me out though, if I'm wrong. Then...
Yeah, because I mean, I just calculated out and I got 1.15.
Okay. No problem. Check out the graph in your supplement book right here. And if I'm wrong, let me know. All right, moving on to our last section here. We'll finish off with some figures that the FA wants you to know how to use for the knowledge exam. And a discussion page here for your questions. The first chart that we look at might look like a bit of a monster. It's really 3 different charts combined into one. So let's kind of deconstruct this so you understand it. First line to look at is starting at the origin point here. And it's running in this fashion here. And it's got this label called C sub L. So that is your coefficient of lift curve. So we've covered that earlier in class today. It has a point, the stall point, CL max. No problem there. The scaling for coefficient of lift is in this spot right here. So keep in mind when you're reading different curves, go to the correct scaling for it. Just a little bit up from the origin here, we have another curve. And it kind of looks like one half of the drag curve. So if that's what you're thinking, you are correct because it's labeled C sub D, coefficient of drag. Of course, we can very easily see as the closer we get to the critical angle of attack, the exponential increase of the drag factor is occurring. Coefficient of drag has its scale on the far left side. Now, your questions are all going to be from the other line coming out of the origin. It has this interesting curve to it, and it's labeled L over D, lift over drag. And it's also giving you the high point where you have the maximum lift to drag ratio. Remember, that would be your best glide or best range spot. And on the far left side is the scaling for lift over drag. So all your questions come from that one right there, that one curve. All right, so let's try a top hat question. Let's use the chart. If you want to use your book to help you out, it is figure 3 in there. This is going to be one of a touch point question on top hat. So this will help you find out where to touch. So you're going to find the lift to drag ratio for a 10-degree angle of attack. And this is, again, a touch point. So you're going to touch where you should be looking on the scale. So make sure you touch on the scale. We got a very, very easy thing to do. You start at your 10-degree angle of attack, move up until you get to the lift to drag ratio curve, and then move right. Very straightforward. Make sure you're touching the scaling, the proper scale, where you should be looking for it. All right, so far right side, that's the scale we should be looking at. So some of you put it on the coefficient of lift. One of you put it on the coefficient of drag scales. Okay. A lot of you just touched the curve right there, but your actual scale's on the far right side for it. Okay, so now we got everyone knowing where to look for your numbers on this. How do we use these numbers that we find? The FAA is going to give you a glide question. And we're going to use that lift to drag ratio as the ratio of how many feet forward we go per 1 foot of altitude loss. For this problem, you do have to know that a statute mile is 5,280 feet. And you do have to know that a nautical mile is 6,076 feet. Those numbers will not be given to you, so make sure you do know them. All right, so given an angle of attack of 16 degrees, what is the altitude loss over 2 nautical miles? So using that figure 3, we would find 16-degree angle of attack. I'll give it to you here, and you can double check me. It comes out to be 7.8 degrees. So you do want to make sure you understand scaling on here and that you are able to find as close to the number as possible to mine. If you perhaps got 7.9 or 7.7, you'll be within tolerance here. Okay? But 7.8 is the number for the lift to drag ratio. What that simply means is for every 1 foot that you drop in altitude, you go forward 7.8 feet. Or you could say it, every time I go 7.8 feet forward, I lose 1 foot of altitude. And we're going to keep doing this over 2 nautical miles. Right, so we have our lift to drag ratio. We'll take our distance, since we're talking nautical miles, 6,076 feet. Okay. So don't use miles. You convert it into feet, divide it by the ratio, 7.8. And this gives you 779 feet of altitude loss over 1 nautical mile. Just simply multiply that by 2, since the question asks for altitude loss over 2 nautical miles. So your answer becomes 1,558 feet. So just to recap, from figure 3, at an angle of attack of 16 degrees, that equates to a lift to drag ratio 7.8 feet. Every time you go 7.8 feet forward, you lose 1 foot of altitude. All right, taking a look at another of the FA charts. The VG diagram. This is a figure 5 if you wanted to take a peek at it. You can see the standard positive lift line. You can also see the negative lift line, and you can see the positive load limit. You can see the negative load limit, 3.8 Gs and negative 1.5 Gs. So you can see everything in there. You can see where the yellow arc is, operating in the caution range. It includes these little diagonal lines, solid lines here, with labeling like a positive 15 feet per second. These are gust factors. So if you were flying and you suddenly hit a gust that took you up 15 feet per second, that's introducing a load on the airframe in addition to your lift. At present time, the FAA does not ask you any questions on those gust factors. They simply ask you, what is point C? What does point D to G represent? What's E to F represent? Those are the type of questions they ask you here. So no worries with that one. The last chart we'll leave you with today is actually a combination of two different ones, and this is going to be figure 4. We've combined two different charts, being the stall speed increase factor and then the load factor itself. So bottom, the x-axis is going to be the bank angle in degrees. When we look at a stall speed increase, of course the curve is properly labeled here, your scale is on the far left side for percent increase in stall speed. So your origin point is 0 down here. If you're dealing with load factor, your scaling's on the far right side, and your origin point starts at 1G. Again, you find your bank angle, you go up to the appropriate line, go over to your scale. Very straightforward chart. So let's try top hat question here. Find the load factor for a 40-degree bank angle. So again, you're going to be touching and touch on the proper scale. So you're going to go to one side or the other of the chart to touch your answer there. 40-degree bank angle, load factor. So start at 40, go up to the appropriate curve, go to the appropriate side for your scale, and touch your answer. All right, most of you got that one over there. Looks like one of you just touched on the curve itself, so you should have went to the side. All right, this one, we're going to find the stall speed increase percentage for a 40-degree bank angle. Now, start at the x-axis, the bank angle, go up to the appropriate curve, go to the appropriate side, and touch your answer. Oh, interesting. All right. Most of you got that one correct. You went to the left side. Several of you went to the right side. That's load factor over there. We have to be on the left side for this one. So you're looking at somewhere just over 15, about 16% increase on that. All right, so just an example of that. 80 knots, if we have a 30-degree bank angle, our increase in stall speed, we start at the bottom, 30 degrees, move up to the correct curve, and over to the left, we see a 5% increase in stall speed. That equates to 4 knots increase, and 84 knots would be the answer. So there we go. Load load factor 50 degrees on over. So there we go. A couple different examples for you. See if you have any questions. No questions. Any verbal questions? All right, well, you made it to the end of class. You have a lot of assignments to get going on, so check those out, and we'll see you all next time.